Hello again, Mr. Wakefield here, looking at 8.2 now, and we're looking at multiplying and dividing fractions now. The way we multiply and divide fractions, especially when you got bigger polynomials inside of your numerators here and your denominators also, is definitely something we need to be very careful about. We don't want to just multiply right away. If we do that, we'll end up with an answer that is difficult, if not impossible, in a lot of cases to put into lowest terms. And it is a requirement that these answers need to be in lowest terms. Because what you're going to do is you're going to get a fraction normally as your answer, and it needs to be in lowest terms. Okay, but if you follow the directions I have here, which thankfully are very similar to the last section, 8.1, you will end up with an answer in lowest terms. Okay, so let's talk about how we go about that. First of all, when you have a single term in all four places here, the two numerators and the two denominators, okay, you don't need to do the first couple steps up here because the first couple steps involve factoring. And as we've talked about before, when you factor a numerator or denominator, you don't need to factor a single term. What do we factor always? We always factor either a 2-term polynomial, a 3-term polynomial, or a 4-term polynomial. But we never do a single term. Okay, so skipping those first two steps, that means we can jump right down to step 3, which is, it says divide out, but that's the same thing as canceling. Okay, the way we cancel is the same way we did in 8.1. This step is going to be very similar to 8.1, where now, instead of just having, and let's take a look at 8.1 here as a comparison side by side. Remember this problem right here. Problem A in 8.1, we just, since there was a single term on top and bottom, no need to factor. You just start canceling. You start out with the coefficients, and then you do the variables if they're the same. Okay, and that brings us to, that's all you got to do. All right, so it's the same thing here where we have, the only difference is that we have all four places here. Don't multiply yet, just cancel in the same way we did here. Okay, the difference though, since we've got two numerators and two denominators now, is that you are, and I wrote this note up here, you can cross cancel. Meaning you can cancel, for example, the 12 with the 42, or the 25 with the 35, or the K3 with the K6. Okay, you can do all that. You're allowed to do that, but only when you're multiplying fractions. So if, for example, let's say there had been a plus sign in between the two fractions instead of multiplication, then you wouldn't be able to do the 12 and the 42 and the 25 and the 35 and all that stuff. You wouldn't be able to do it in that case. Okay. And like always, don't ever cancel something on top with something on top. That's not what I mean by cross-canceling. It still has to be something on top with something on the bottom. Okay? And it has to be, whenever you cancel, and we saw this in 8.1 as well, it's got to be one thing on top with one thing on the bottom. You cannot do 12 with 35 and then do 12 with 42 at the same time. It's got to be one thing on top and one thing on the bottom. It doesn't matter if it's a green factor like we saw in the previous section, the single term factors like we saw, or if they're red factors, it doesn't matter. It's got to be one with one, okay? One with one here, all right? So, for example, see how we got x minus 5 and x minus 5? If this had been x minus 5 also, you would not be allowed to do x minus 5 here with both of the x minus 5s down here if they were both x minus 5. It still has to be one red with one red. It still has to be one green with one green. Okay, so if there had been more than a couple greens here, you'd still have to just match up. It would be required to just match up one green with one green. We'll see that more here as we go along, but I wanted to clear that up there. Okay, so what can I do first here? Remember, we're allowed to cross-cancel, and we don't have to do any of the factoring stuff first here. All right, in fact, if you want to think of it this way, these are all green, all right? Because whenever your numerator or denominator is just a single term, that is considered a single single term factor, and that's why they're green. Okay, so and remember, the green, in case you can't see the green very well on the screen here, the green is just the single term factors. Okay, so these are all green. They're all single term factors, all 4 of these things. Okay, so let's get started here. You're allowed to match up a green with a green. All right. So I can do, for example, it doesn't mean you have to start with this, but you just keep on going until you can't cancel anything else. And I'll go over that here more as we go through this. But I'll start out with 25 and 35. Since those are both coefficients, I can divide both of those by a common factor. 5 is a common factor there. That would give me 5 and 7. Now, that doesn't mean that 5 and 7 can't still be canceled again. Okay, so what are my coefficients that I have left here? 12, 7, 5, and 42. Okay, so if everything is just a single term here, all right, you got to look at your coefficients and make sure that they've been canceled as far as they'll go. I can also do 12 and 42, can't I? All right, I can divide both of those by 6, in fact. Okay, so 12 and 42, that gives me 2, and 12 divided by 6 is 2, and 42 divided by 6 is 7. What I got left now is 2, 7, 7, and 5. Okay, you look at your coefficients. Is there any combination that will cancel where you pick 1 on the top and 1 on the bottom? No, there isn't, because 2 and 7 don't work. 2 and the other 7 obviously don't work. The 5 and the 7 don't work, and then the 5 and the other 7 don't work. So any combination of 1 coefficient on top and 1 on the bottom, none of them cancel, meaning that the common factor of any of those different pairs that I just pointed out is 1. And of course, that means it's in lowest terms, because if you divide by 1, it's not going to make it any lower. So we're done with the coefficients. Now, what did we do in the last section when we had single terms on the top and bottom here again? Once you do the coefficients, you then do the variables if the variables are the same letter. Okay, and they are here, K and K, so that means that we can do what? I can, again, take the 3 and the 6, and I pick what? I pick the smallest exponent there, which is 3, and I subtract 3 from both of those. Okay, and so I get what here? I get K3 and K6. So if it's 3 minus 3, that's going to be K to the 0, which is equal to 1. And then 6 minus 3 is going to be K to the 3rd, which is going to go on again. 6 minus 3 and 3 minus 3. All right. K to the 0 is 1. And then 6 minus 3 gives me K to the 3rd. So what we do then is we, just like we did in this problem in 8.1 over here, we then multiply together the new parts here. Okay, we did that with 11 times x to the 4th and 1 times 1. Same thing here. Okay, let's clean. Since we got 2 fractions though, let's clean up our mess here first. Let's not try to multiply the fractions together yet, because we want to know what we're multiplying first. Here I got 2 times 1 on the top of the first fraction. That's 2. Here I got just 7 on the bottom of that. Bring down the multiplication symbol. On the second fraction, I got 5 on the top. And underneath that, I have 7 times K3. Okay. Now I'm ready to, since I've cleaned up my mess and I know exactly what I have in the 2 numerators and the 2 denominators, I now can clearly multiply the fractions together, but you got to cancel first. Do all that canceling first. So then if I multiply these together, 2 times 5 is 10. Remember, when you multiply fractions together, it's the tops and the bottoms, right? Okay, multiply the tops together, multiply the bottoms together. Okay, and if you did it right, this should already be in lowest terms. You can go ahead and double check. Just by, since there's a single term on top and bottom, you can try to put this in lower terms by looking at what we normally do in that case, the coefficients and then the variables. But you can see that this is already in lowest terms. And it, like I said, if you canceled everything that you possibly could here, you did all the coefficients as far as they go, and you did all the common variables on the top and bottom, then like I did with the K, then it should be done already. All right, but you're always welcome to double check at the end. All right, I'm just saying that if you've already done the previous steps correctly the way I showed you, it should already be in lowest terms. There shouldn't be a worry about that. Okay, now here's the thing, you guys. Here's the big thing. Once we get into these problems where there's more than one term on the top and bottom, see how there's two terms here? Two terms underneath it, separated by minuses and pluses. Three terms here in this numerator, and then two here. When that happens, if you have at least one numerator or denominator that has more than one term in it, here all four of them have more than one term, but if there's at least one that's got more than one term, that makes it a different problem than this one is. You have to go through the whole process of factoring, or at least try to factor. Then identify your factors. That's the part where you underline the green factors and the red factors, just like we did in the last section. We'll review that here. And then we cancel in pretty much the same way that we did in the last section. Again, it's just that you can only cross cancel when you're multiplying fractions. That's a key thing to remember there. But since we are multiplying here, that'll be fine here in this problem. Okay, since we already know how to factor, I'm going to go through this a little bit quicker than normal just because we learned that already in the last section. That way we can get to the new stuff that we haven't learned yet. Okay, so you're always welcome to let me know if you have any questions about, how did I get that factoring. But this right here has a GCF. And then as you guys know now, the 4v minus 1 is prime because, as we talked about when we're factoring, if you have two terms and it has a variable to the first power, that's automatically prime. Okay, not including those problems where you're on the last step of the Berry method and you still have to factor out the GCF. Okay, in that case, you still got to do that step. But if you've just factored out the GCF, okay, and you get a bracket with two terms and variable to the first power, v to the first power, okay, that means it's prime, right? Okay, as we've talked about a number of times. And if you get down to that step where you end up producing two brackets and the Berry method's completely done, okay, and you end up with the same situation, we'll see that here in a second, two terms and a variable to the first power, then that means that those brackets are prime also. We'll see that here coming up. Let's do this one first, though. The GCF here is 4. That gives me 2v plus 3, and again, that's prime. Okay, it's not the Berry method. It's not the last step of the Berry method, okay? It's got two terms with v to the first power. That's prime. We know that. Here, 2 times 12 is... negative 12, pardon me, is negative 24. And the two numbers that add up to negative 5 from negative 24 would be negative 8 and 3. And so, there we go. And so that would be what? That would be 2v minus 8 and 2v plus 3. But that's just the first step of the Berry method. Okay, now I mentioned, if you got a bracket with two terms and v to the first power, that's prime. But this is the one exception to that, again, because remember, you're not actually done with the factoring yet here. You're just on you still have to do one more step of the Berry method. Okay, so the last step is to what? It is to factor out the GCF out of each one of these brackets. We get v minus 4 and 2v minus 3 stays the same because the GCF of that is 1. The GCF of this one is 2, so if you factor that out, you get v minus 4. And remember, in the last step of the Berry method, you do not keep the GCF that you factor out. You just throw it out. Okay, and now that we're done with the Berry method, now we can look at these brackets and say to ourselves, oh, hey, these have two terms and they have v to the first power. Both of them do. And so they are prime. We don't need to try to factor any of these two brackets down to more brackets. Okay. And then down here on the bottom we have 3. V minus 4 factors out of that. And v minus 4 again is prime for the same reason. Okay. Two terms, v to the first power. Okay. So now... just like we did in the last section, all right, what did we do in the last section? After we factored, if we had a term times a bracket in either a numerator or a denominator, that was a green and a red. If we had a bracket times a bracket with more than one term inside of each, okay, that would be a couple of red ones, because red means that there's more than one term, okay, in that particular factor. And so let's do that here, okay. 2 brackets with more than one term inside of each, that's 2 red ones. And then whenever you have a term times a bracket, that's a green and a red. Okay, so I'll do that here. Okay, what did we do in the last section after we identified all of our multiple term factors in red and our single term factors 3, 4, and 3 in green? Okay, what we did was we started out with the green ones and we just canceled them the same way you normally would if they were their own separate fractions. So for example, if you combine together the 3 up here and the 3 down here, which you're allowed to do because we're multiplying, so you're allowed to cross cancel, it would just be the same thing as doing 3 divided by 3, okay, and putting that in lowest terms. Wouldn't that be 1 over 1 if I divided both of those by 3 right there? So you can do that with single term factors. 1 and 1, okay. What do I got left? And remember, you can only do 1 green on top with 1 green on the bottom. You can't do 3 and 4 at the same time you do 3 and 3. Okay, not that 3 and 4 would work, but even if this had been, say, a 6 right here, you couldn't do the 3 and the 6 with the 3 and the 3 at the same time. It's got to be 1 on top and 1 on the bottom, 1 pair at a time, okay, that you're canceling. So what do I got left here as far as the green ones go? 1, 4, and 1, right? Nothing else cancels out of that, right? 1 doesn't cancel with the 4, 1 doesn't cancel with the 1, okay, and so the green ones are now done. All right, so we cancel the green ones when we're multiplying fractions exactly the same way we canceled them in the last section. Okay, it's the same thing with the red ones too. We cancel those the same way. And by the way, I apologize here. I know that this is a plus because it was a plus up here. I forgot to bring that down. And so please put that plus there if you haven't done that already. But remember what we said in the last section in regards to red factors. If you have one red factor on top that's exactly the same as a red one on the bottom, there's also that special exception where sometimes you have the same terms but opposite signs. Okay, remember those problems right here. Keep an eye out for those as well. Those also cancel. But usually with the red ones, you're going to see some that are exactly the same. So if it's one of those situations where you got the same term and opposite sign, okay, you can cancel those. Otherwise, they need to be exactly the same, talking about the red ones, in order to be able to cancel them. Okay, so do we have some that are either exactly the same or they have that opposite sign thing going on? Yeah, we got a couple of those situations here, don't we? We got this one here and this one here. And when they are exactly the same, it becomes 1 and 1, just like it did in the last section. 2v plus 3 and 2v plus 3, those are exactly the same. So they become 1 and 1 as well. And that's it, right? Because the only, not including the ones here, the only red one left is 4v minus 1. And so you can't cancel that because there's not another 4v minus 1 or something similar with the opposite sign thing going on to match up with the 4v minus 1. Okay? And so that's all that we can do as far as the red ones. So we are now done doing the green ones. We did that as much as we could. And we did the red ones as much as we could. And so if you're done with both the greens and the reds, you are now ready to clean up the mess just like we did over here when we were done canceling. All right, let's clean up our mess here. Whenever you have 1 times a bracket, you guys, it's okay, at least on this next step here, to just say the inside of the bracket. Okay. We saw that in the last section as well. If you have 1 times a bracket, you can just say the inside of the bracket. If it's anything else other than 1 being multiplied by the bracket, that's a different story. And we'll see that. We'll review that again here. Underneath that, we have 4 times 1 is 4. And then in this fraction over here, we have 1 times 1 on the top is 1. Underneath it, we have 1 times 1 as well, which is 1. And so what happens here, now that we've cleaned up our mess, just like I did over here, we're now ready to multiply those fractions together. Okay, and anytime you multiply a numerator or a denominator times 1, it's just going to be equal to itself. Now, this should already be in lowest terms, like I promised. As long as you did all the steps in the way that I explained it, it should all be in lowest terms already. But if you have any doubts at all, you're wondering, oh man, I think I should cancel the 4, but I'm not sure. Well, the way to check your answer, if it's supposed to be something that's in lowest terms, and when you do multiply and divide fractions, it is supposed to be in lowest terms. Okay, same with the adding and subtraction, and as we'll see when we get to that section, when we add and subtract fractions as well. The way to check that this is in lowest terms is, again, just like I mentioned in the last section, take your answer and pretend like it's the beginning of the problem, and pretend like you're supposed to put this in lowest terms, just like in section 8.1. Okay, well, this is a red factor, just a single red factor because it's prime. It's got a GCF of 1. It's got 2 terms with v to the first power. Okay, and so that is prime if it has a GCF of 1 and it has 2 terms with v to the first power automatically. This is a single term down here, so that's a single term factor as well. And as we mentioned in the last section, you can never cancel a red with a green, ever. Even if the numbers are the same, it doesn't matter. And so that's why I know that this is in lowest terms. Just as again, it's optional to do that double check right there. All right, but if you do, then you can see that the 4s don't cancel for that reason. You can't do a red with a green. Okay, can't do a multiple term factor with a single term factor. Okay, so that's multiplying fractions, you guys. What about dividing fractions? Okay, well, anytime that you, let's start off by saying that anytime you have a fraction, and it doesn't matter if you're adding, subtracting, multiplying, or in this case dividing, does not matter, any of those 4 things, if you have a fraction and then another thing that's not a fraction, the first thing you want to do, you guys, is make that other thing into a fraction so that you now have 2 fractions. Okay? And then the second thing we need to remember is that since this is division, and you need to do this first, okay, after you make that into a fraction, that is. But if you have a fraction divided by another fraction, now that it's a fraction over here, you then first need to flip the second fraction, not the first one, but the second one. And what that does is it converts the problem into a multiplication problem simultaneously. So the division symbol becomes a multiplication symbol, and then the fraction becomes flipped. The second one, though, again, don't flip the first one, only the second one. Okay, why is it so important to do that first? It's because remember we said a few minutes ago that you're only allowed to cross-cancel when you are multiplying fractions. You can't do it when you're dividing fractions. So you got to convert it to a multiplication problem before you start factoring and canceling. Otherwise, you won't be able to factor and cancel everything. Okay, and also if you don't flip it, you're going to end up canceling the wrong things anyway. So because it is supposed to be flipped and become a multiplication problem. But also it's important because you can only cross cancel when you're multiplying, not dividing. So do that flip thing first. Now that it's a multiplication problem, you guys, it just becomes the same as the last problem here. Factor everything that you can, and then cancel everything that you can. Now remember, the 1 and the 4h, those are both single terms in your numerator and denominator, and when that happens in a numerator or denominator, that's just a single green factor there. You don't have to factor that. This right here, however, is the Berry method. 1 times 108 is 108, and for that, minus 9 and minus 12 would add up to minus 21. And you don't need to do the last step of the Berry method there either, because these 2 brackets already are the GCF of each one of those is 1. So if you try to do the last step of the Berry method where you factor out the GCF, it's not going to change it. It stays the same there. And then what's this factoring here? Well, notice that this is 12 squared minus h squared, isn't it? So wouldn't that be 12 minus h, 12 plus h, both of those in brackets there, like that. Okay, and so now I have factored everything, okay? Remember when you have two brackets in your numerator denominator with more than one term inside of each one of these have two terms inside of each bracket. That's two red ones. Same thing here for the same reason. These are two red ones. And like I said a minute ago here, the 1 and the 4h are red. Okay, so I'm sorry, they're green. The 1 and the 4h are green because they both have just a single term there. And so what do we do first here? Always, after we've identified all of our reds and greens, what we do is we try to cancel the reds if we can. The 1 and the 4h don't cancel, do they? It would be just like if you had 1 and 4h as its own separate problem. Isn't that already in lowest terms? If it wasn't, then you would have something to cancel. Since it is, however, then you leave the 1 and the 4h alone. So since the 1 and 4h don't cancel at all, we skip the green step and we move on to the red step. The red step is where you cancel if you have a red one on top and a red one on the bottom that's exactly the same, or if it has that same term opposite sign thing going on. Okay. You can see here that h minus 9 doesn't cancel with anything down here, but the h minus 12 cancels with this, not this one over here, because remember, you can't cancel if one of the terms has the same sign but the other one's different. See how you got positive h, negative 12, positive 12? You can't cancel that. But you can cancel if both of them have the opposite sign. Positive h, negative 12, positive 12. In that case, you can cancel if both of them have the opposite sign, and it becomes negative 1 and 1. Negative 1 and 1. Okay? And so, what does that become here? Again, let's clean up our mess. All right, here we have, and whenever you have a red one times just a single term, which is what this now becomes, it was a red one before, it just becomes a single number here, negative 1. If you've got, let me say it this way, if you have a red one times anything that's not equal to 1, okay, the 4v minus 1 here was multiplied by positive 1, that's different. But if a red one, a bracket with more than one term in it, okay, or just any red factor, a factor that's more than one term in it, if it's being multiplied by anything other than positive 1, you have to keep it bracketed. In fact, if it's just a single number being multiplied by that, we usually put the single number in front. As we've seen many times before, okay, when you have a single number being multiplied by a bracket, we usually put the number in front because that's just how it's usually written. And you're allowed to reverse two things that are being multiplied. That's okay to do that. Because these two things are being multiplied together, the negative 1 and the h minus 9. It's okay to put the negative 1 in front then. Okay. You might be wondering, should we distribute that out? You can, as long as you're sure you've canceled everything already, you could do that. Just remember that the negative 1 has to be distributed through both of these here because the bracket cannot be gotten rid of without multiplying it. Okay. If you're multiplying by anything other than 1. Over here we were multiplying by 1, and so you could just say it's equal to the 4v minus 1 without the bracket. Anything other than 1, you either keep the bracket or you take that number and you distribute it through the bracket. It's your choice, but if you are going to distribute it, you got to make sure everything's canceled first. Okay, and so anything other than 1 being multiplied by bracket, okay, you either distribute it out as long as everything's canceled, or you just keep it like this, which, as I mentioned in the last section, it's okay to keep your brackets, all right, in these problems when you do all this canceling. In other words, the problems where you're doing the lowest terms, like in 8.1, or the problems where you're multiplying and dividing, which is very similar. to the 8.1 problems. You can keep the brackets, all right? And then here, since we have positive 1 times 12 plus h, you can get rid of, at least on this step, the bracket there, okay? But here's the thing. We still have one more step to go because we still have to multiply the fractions into one fraction here. I was just cleaning up my mess here like I did in the previous two problems where I figured out what each numerator and denominator was equal to by multiplying the different parts together. Negative 1 times h minus 9. Okay, I wrote that down with its bracket there. Okay, 1 times 12 plus h. I cleaned up that mess. Now I need to multiply the numerators and denominators together. Anytime you multiply by 1, it's equal to itself. So it's just equal to that right there being multiplied by 1. Now here's the thing, you guys. I know I just got rid of the bracket, but we're going to need to bring it back. Okay, I know it's kind of weird, but when you multiply a bracket times 1, you don't need the bracket. However, what you need to realize is that we now need to take the 12 plus h and multiply by 4h. And here's the thing. If you have a numerator or denominator, doesn't matter which one, numerator or denominator, this is a denominator here, you have to multiply the entire denominator times the entire other denominator. And so that means that if you have a denominator with more than one term in it, you have to bracket it when you're multiplying it by the other denominator, like that. Okay, anytime, and I'm sure I've said this before, but let me say it again carefully. Anytime you have something with more than one term in it and the whole thing, in this case, the whole denominator needs to be multiplied. If the whole thing needs to be multiplied by something else other than 1, okay, other than the number 1, then you need to bracket that. And so that's why I bracketed these two terms here. Okay, so the numerator denominator, if they have more than one term and you're multiplying it by the other numerator denominator, you have to bracket that. Okay. And we'll see that again here, don't worry. So yes, you can distribute out these brackets here if you want, as long as you're sure you've canceled everything first. But again, in the multiplying and dividing problems, just like the lowest terms problems, it's not mandatory. Okay, let's do one more here, and then I'll let you guys try some. Again, division means what? It means that we flip the second fraction and simultaneously change it to a multiplication problem. Zoom in a little bit more. There we go. And so first fraction stays the same. Second fraction flips. It becomes a multiplication problem simultaneously. So put your multiplication symbol there. Then we factor everything, because this is not one of those problems like up here where everything's a single term and you don't have to factor. Okay, if you have more than one term in any of your 4 different places here, okay, then you have to factor that thing, or at least try to. Speaking of that, these 3 things are all prime. They all have a GCF of 1. All 3 of these things I underlined. And they all have 2 terms with x to the first power. So they're kind of nice to us here. We don't have to do that much factoring. We just have to factor what? We just have to factor this thing. Okay, what does that become when I factor that? Let me rewrite the rest of the problem here, since the rest of the factoring has already been attempted here. There we go. Put that back in there again. And then we do the Berry method on this. 3 times negative 2 is negative 6. We need 2 numbers that add up to negative 5, and that would be negative 6 and positive 1. So that means that we're going to have, let me just do this off to the side here, 3x minus 6 and 3x plus 1. But then I have to factor out the GCF out of each one of those brackets to get my final factoring. If I factor a 3 out of that first one, I get x minus 2. And if I factor the GCF out of the other one, it doesn't change because the GCF is 1. And so that's your final factoring right there for the Berry method. Okay, these 2 brackets here. Okay, so we're going to get what here? We're going to get x minus 2 and 3x plus 1. And now that I have factored everything and I've identified my factors, I am now ready to what? I am now ready to cancel whatever I can. And there are no green ones this time, so we skip the green step. No single term factors. But then we cancel the red ones if we can here. And there's a couple that are exactly the same here. So I do 1 and 1 right there. And nothing else is exactly the same, right? And nothing else has that opposite sign thing going on either, does it? Okay, so all the other red ones cannot be canceled. Let's clean up our mess here. Okay, we get what? 1 times 3x plus 1. Okay. Again, when you multiply a bracket times 1, you don't need to keep the bracket. Yes, we're going to put the bracket back in there on the next step, but I'm just saying you can, on this step, you don't have to put the bracket there if you don't want to. You can still keep it if you want, since we're going to put it back on there in the next step in this case. But you don't have to on this step when you're multiplying by 1. And then the other things, you got the 1 underneath here. But the other, nothing canceled on the second fraction there, so I'll just bring that down, or I'll bring that into the next step here. And then what does that lead to here? What is that going to become? Remember, when you have 2 terms in a numerator or denominator, 2 terms and it's being multiplied by the other numerator or denominator, and that other numerator or denominator is not positive 1. It is not positive 1. It is something else other than positive 1. Okay, it's x minus 3. In that case, you have to bracket the 3x plus 1 because it's being multiplied by something that's not just 1. It's x minus 3. But the x minus 3 also has 2 terms, and it's being multiplied by something that's not equal to 1 either. And so that also needs to be bracketed. Again, I'm going to say this a lot. I've said it a little bit already. 2 terms, 2 or more terms. And if you have to multiply that whole thing by something other than 1, okay, and each thing needs to be multiplied by the other numerator here, then you need to bracket those things that have more than 1 term in it, okay? And so that's why we bracket both of those. Again, you don't need to multiply out these brackets if you don't want to. If you insist on it, then you have to wait until you're done canceling, which we are, so you could if you wanted to. Now on the bottom here, like I said, x plus 1, that has 2 terms, but you're multiplying it by positive 1, and that's it. And so it's okay if you want to just write it like that. You don't need a bracket around that because it's being multiplied by just 1. If you put a bracket around it, it's not the end of the world there. It's fine, but you just don't need to when it's being multiplied by positive 1. Okay. And there you go. Okay, so please try 1 through 3, a very similar thing to what we're talking about. Don't forget in problem number 3, you got to flip, okay, because it's a division problem. Do that first before you start factoring and canceling, and then you should be fine. So go ahead and try that, hit the play button, and we'll take a look at those 3 answers after that. Okay, number 1, again, there's more than 1 term in all of these numerators and denominators, so we need to factor everything first. I did that right here. And pardon me if these look like they're purple underlines here. They're actually meant to be red. You can see a little bit of red there. But all 8 of these factors here are all red because they all got more than 1 term in it. And so we're going to treat them as such. Okay, so no green ones to cancel. And as you guys know, if you've got a red one on top and a red one on the bottom that's exactly the same, then you can what? You can cancel those and you get 1 and 1. Again, do not cancel x minus 1 twice on top with 1 on the bottom. You have to pair up 1 on top with 1 on the bottom only. So you can't cancel 2 on top with 1 on the bottom. That's not allowed. Okay, so I paired up 1 on top with 1 on the bottom. So this other x minus 1 is still left. And there's not another x minus 1 underneath it to pair up with it. So that's just going to stay there, okay? Can't cancel that. But what else can I cancel in this problem, though? I can cancel the x minus 4 and the x minus 4. And that gives me, again, don't do the x plus 4. The x minus 4 and the x minus 4. X plus 4, it doesn't work because the 4's have a different sign. But the x's don't, so you can't cancel. And so we left with 1 and 1 on that as well. So all we got left here is these 4 red ones still left. Looks like that right there. Okay. Don't need the, at least on this step, you don't need the x plus 4 and x minus 3 to have brackets around it. You could have kept them if you wanted, but because they were being multiplied by 1 inside of their denominators, you didn't need them. But then when I actually multiply the denominators together to get the final answer, I need to bring those brackets back into the problem. X plus 4 and x minus 3 both need to be bracketed because of the fact that they're each 2 terms and they're being multiplied by something other than 1. Okay. The reason why there's still brackets on the top here, by the way, even though it's being multiplied by 1, is because these 2 brackets are still being multiplied by each other. Okay. And so the fact that they're being multiplied by each other and neither one of them are equal to 1. Okay. In other words, x minus 5 is not being multiplied by 1. It's being multiplied by x minus 1. So that's why that has to stay in brackets. The x minus 5 does. It's because it's being multiplied by something that's not equal to 1. And x minus 1 is being multiplied by something not equal to 1 either. So because of the fact they're being multiplied by each other, you got to keep the brackets there. But if something is being multiplied, if you just have one bracket like x minus 3 right here, and it's being multiplied by 1, and it's just that bracket and the 1, then you don't need the bracket on that next step there. That's the difference. Okay, so that's problem number 1 there. And let's move on down here into number 2. Okay. So again, multiply, so I factor everything, but the 4 and the 16 do not factor. They're just single terms, so they're both green. There's a GCF on the second numerator, 2 times bracket 2 minus x. The x minus 2 is prime. Okay, what can I cancel? Let's start out with the greens. Remember, you can't do 4 and 2 both with the 16 at the same time. You got to pair up 1 on top and 1 on the bottom. And it's just on the green step. 1 green with 1 green. And you keep on pairing up 1 green with 1 green until nothing else cancels anymore. So I can either do 4 and 16 or I could do 2 and 16. It doesn't matter. It's going to come out the same either way. But if I do 4 and 16, I get 1 and 4, right? So what do I got left amongst the green ones? I have 1 replacing the 4, 4 replacing the 16. So I have 1, 4, and 2 still. Can I cancel anything if I pair one green one on top with 1 green one on the bottom? Yes, I can cancel the 2 and the 4, right? And that gives me 1 and 2. All right. So what do I got left now amongst the greens? The 1, and the 2 are all that's left. Just amongst the greens. We haven't touched the red ones yet. Okay, so 1, 1, and 2. We're done with that. Can't cancel anymore amongst the green ones. And then as far as the red ones are concerned, we have that same term opposite sign thing going on. -2, +2, positive x, negative x. And so that means that we can cancel those and we get -1 over 1. Cleaning up my mess down here, I get 1 over 1. And then 1 times -1 is -1 right here. Okay. And then 2 underneath that, as you can see there. And then if I multiply those 2 fractions together, I get -1 over 2. That's problem number 2 there. Okay. Finally, number 3. Zoom out a little bit more. There we go. Remember, since it's division, we got to flip it first. Okay, we flip it first here, and we get, haven't done any factoring yet, I just flipped it. That becomes multiplication of this simultaneously there. These 2 things now factor. We're now ready to factor because it's a multiplication problem. Again, don't factor until you make it into a multiplication problem, because I don't, for one thing, not that this is the only reason, but mainly I don't want you to accidentally cross cancel something when it's not a multiplication problem. That's the big thing. So if we do the Berry method on these 2 polynomials here, you get this right here. These 2 are both prime, and so everything's red. So what can I cancel amongst those red ones? I can cancel the x minus 2 and the x minus 2. And also I can cancel the x plus 3 and the x plus 3. Since they're both identical, they just become 1 over 1 on both of those. What do I got left? 1 times 1 on the top of the first fraction. X plus 6 times 1 underneath it. Again, you're multiplying by 1. You don't need the bracket there, at least not on this step. And then x minus 1 over 1 here. And then when you get to the final step here and you multiply the fractions together, since the x minus 1 this time is being multiplied by just the positive 1, you don't need to keep the bracket there either. Again, more than one term being multiplied by 1, you don't need to bracket that thing that's got more than one term in it, that numerator. Same with the denominator. 2 terms here, you got to multiply by the other denominator, but it's positive 1, so if you're multiplying by positive 1, the bracket is not needed. Okay, and then I just double check my answer. Not mandatory if you've done all the other steps correctly, but I just double check to make sure I couldn't cancel anything else by realizing that both of these are red prime factors here. That's why I underlined them, and they're not. These aren't the type of red factors that you can cancel here. Okay, remember you're not allowed to cancel part of a red factor. Okay, so that's why you can't cancel the x and then leave the negative 1 and the positive 6 left over there. You're not allowed to do that. You either cancel all of a red factor or none of it at all. Okay, as we talked a lot about that in 8.1 as well. So this concludes 8.2. As you can see, there's a lot of similarities with 8.1. But when we learn how to add and subtract fractions in the next couple of sections, that's going to be a whole different story. Okay, but when we multiply and divide fractions, very similar rules to 8.1 when we just learned how to put a fraction in lowest terms. Okay, so remember, adding and subtracting is going to be totally different. All right, so we need to be ready to separate that idea, the adding and subtracting, from multiplying and dividing. Okay, it's going to be a whole different thing. Okay, but I'll see you back for 8.3, and 8.3 and 8.4 together are going to help us learn how to add and subtract fractions. Okay, so we'll see you back for 8.3. You have a good day and take care.